Hello and welcome back, hopefully, and thank you for joining me on my journey as I try to create my own Mega Drive game using SGDK on Linux. So this is a revisit of my attempted development environment setup from my first video. In the time since that video, I went back, looked over the ChatGPT output and discovered that I missed a step where I needed to actually run sudo make install in Marsdev to get the mars.shell script where it was supposed to be. I missed that step, which is why it failed, and I ended up going down that container-based build path. Now, I went back to try and get a native installation of Marsdev and SGDK running again, because that will allow any code editor I use, whether it's CLion or VS Code, to be able to inspect the libraries themselves and offer code suggestions and documentation and auto-completion. Although not technically impossible, if I was using container-based Marsdev and build tools, that would be a lot more challenging to do and maintain. So to prove that I've got it functioning, I've removed my original copies of Marsdev and SGDK. It turns out you don't need to separately make a clone of SGDK. That is one of the things that Marsdev can do for you. So rather than going through the ChatGPT approach, I've actually brought up the README for the Marsdev repository on GitHub. So he's got this nice section in the occasionally asked questions, I really like that, where he says, whatever man, I just want to use it on Linux. So, okay, this stuff we've already done. We will make a fresh clone of this. Okay, so over on our terminal, we will clone down Marsdev, change into the directory. And from Marsdev's instructions, we didn't use recurse submodules, so we can run submodules init and update. We'll do that in our terminal. We have two options for building GCC, with newlib and without newlib. Not entirely sure what newlib is, whether that's SGDK or Marsdev. There's also 32X, the SH toolchain. So SH is the Super H Hitachi CPU used by 32X. And an updated version was then used in the Saturn, the more you know. Let's just do the 68K toolchain, make that. While this is building, I'll also tease that towards the end of this video, we will have a look at how I did manage to get a project set up and working inside of CLion, where I lifted some of the example code out of Marsdev and took a very quick look at the Aspirite and Deflamask utilities for creating some graphics and a really simple video game music track, and created a demo ROM successfully using CLion. So we'll look at that at the end of this video. Still waiting for the M68K toolchain to build, so we'll jump back over to the browser and call out this section here, building SGDK. The original ChatGPT suggestions mentioned cloning SGDK separately, but this make SGDK target can be done inside of Marsdev, and that will copy down SGDK, build it. The useful thing here, which I ran into while trying to get this working, is that I was trying to build SGDK and there were some tools needed to build SGDK that weren't built, like SJ ASM, which is a Z80 assembler, needed for the Z80 CPU in the Mega Drive for sound. I had to build that manually and some other tools manually before I could then build the SGDK libraries themselves. This target inside of Marsdev takes care of that for us. Also, there are some Marsdev examples where you will want at least these bottom two. Echo stuff, not entirely sure what that's about, but I do recall that there is an example, an Echo example inside Marsdev, and also compression tools for Sonic games. These weren't building by default. If you were to run these build steps or make targets, looks like you should get the tools you need for those to work. I realized that I didn't actually run make on the toolchain with the -J for the number of processors I have, so it wasn't parallel building and it was taking forever. Luckily, the benefit of make is that it only makes stuff that it hasn't compiled yet, so it should be quicker, so it doesn't have to build everything from scratch. Okay, toolchain has finished building. Back over to the Marsdev GitHub page for guidance. We've done the toolchain. Let's now go down here. We need to build SGDK. So let's go make, and we'll use our J again. So it's making its own clones of things that it needs. There we go, that's done. And now we just need to go to sudo make install. We will source the toolchains mars.shell. Now, let's have a look at the example projects. Excellent. So clown mdemu out/rom.bin. There we go, hello world with the moon. That's proven that we're able to now build SGDK ROM projects with Marsdev. So Marsdev then suggests what you do is you go into one of these examples and you copy the makefile. What's in the makefile? Oh, okay. So we will copy this back over to where we put our Megatower project. Let's have a look at Megatower now, and will Megatower build? It does. Okay. That means that the demo ROM that I mentioned earlier has successfully built, but we're not going to have a look at that just yet. You'll have to hang around just a little bit longer. This is going to be a shorter video. So now we're going to switch over to C-Line, where I have project for Megatower set up. Here's my updated demo code, and let me just make sure that things still build. Okay, they did. I was keeping that off screen. Still just got to wait a little bit longer. What we have is we've got our source directory. We've got our resources directory with some bits and pieces I put in there. And we've got the output directory. Now, the key to getting C-Line to do like code completion and know about our libraries and headers for documentation purposes is we need to leverage the fact that C-Line makes use of the CMake system for building projects. It's like a more modern version of Make. Now, we don't need a CMake file as such. The make file you see here is still the one that we copied out of the Marsdev example project. But what we do need to do is create this CMake lists.txt. I barely know what I'm doing with CMake. I just Googled it and had a look at what I would need to get C-Line sort of working with SGDK in terms of code completion. And this looks like the bare minimum. If people are interested, drop a comment down below, let me know, and I'll make this available as a GitHub gist or something like that. So with this CMake lists text file in place, we can, if you need to change that, you could go reload CMake project. Down here, it gives us some warnings because we basically hacked this together. But if we now go over to main, we can do things like go, let's have a look, SPR. Oh, look at that. It's picked up the SPR or sprite functions from inside SGDK. Let's see, add sprite. We'll go add sprite. And it gives us some documentation up here. Because we've got our completion set up properly, we can, if we want to inspect the code inside SGDK library, we can right click. This is a C-Line thing, but I'm sure most editors will do this. And we need to go to declaration or usages. So this is the actual code of the SPR add sprite function inside our local copy of the SGDK library that Marsdev cloned and built for us. So, oh, okay, sorry, it's not the actual code, it's the function prototype, which is a C language thing, in our sprite engine.h include file or header file. I do wonder now we should be able to then go to, what if we go to declaration or usages from here? It's the only usage. Go to implementation. Related files. There are no related files. Okay, there's probably a way we could fix that, but for now I'm happy I can at least go here because this will give us in source code documentation if we're really in a pinch. The other thing I kind of needed to do manually was set up the build and run configurations. So if we look here in C-Line, we can come up and edit configurations. So CMake application, I think that's just a default one it creates when you create the C-Line project. I just created an empty C language executable project in C-Line and then created it from my existing Megatower directory, and it picked up there was already source code and a Git repository there. But to add convenient build and run steps, I created a makefile target called build ROM, and this is basically pointing to the makefile, which is in our Mega Tower directory. There's no special target we need to specify here, so we're basically just running make, and I put the Mega Tower directory as our working directory, and that just runs. You may need to explicitly remove a step in the before launch section, which is the thing I did have to do, which is, you're not seeing it here, but I'll just call that out. So we can run this, and that failed because in my demo earlier I added this line of code here. So we'll remove that. Okay. Back up here, build a ROM. Most importantly, process finished with exit code 0. That means our compiler worked. For the big finale, we go to clownmd emu, so this will actually run the emulator with our output ROM. And we have... oh wait, I selected it. I then need to actually press run. There we go. The background music you heard was supposed to be the bass line from Smells Like Teen Spirit, and it was supposed to loop. But I really knocked this up last night well after my bedtime. So I think the next video will probably be me looking at sketching up very simple architecture and some skeleton code to get started with that. So be sure to join me in that if you're interested. Drop any comments that you've got, anything useful, or it doesn't even have to be useful. It's all engagement. Down in the section below, you know how all this YouTube stuff works. And hopefully I will see you in the next video for this journey. Bye.